Okay, hello everyone. I think we can get started. I think there might be a couple more extra people coming in as we continue through the day. This is recorded, so it will be shared on the YouTube, and hopefully we have some people that's also looking at your great work via that. Firstly, I just want to say thank you to Sergio that helped me with all the arrangements and translating between English and Spanish always. And without him, this would have definitely not been possible. So just thank you very much to Sergio. Then thank you to all the students that submitted their work. It was really great to see all the different things that you guys are doing. And we really enjoyed looking at all your presentations. So thank you very much for that. Then just quickly the schedule, just so that everyone can see. So the first session will start with the AutoESA Library presented by Nicholas. Then we have a bit of a web-based GIS application presented by Mohammed. Then we move to more remote sensing with Sentinel data through Atikul. I hope I pronounced that correctly. And then I don't know if Patrick is here yet. If Patrick is able to join us, then he will tell us a bit about the youth environmental development. Then we have the Spanish session that also now includes one English presentation with Carla is the first presenter. I am not sure what the title is, but it's something with California, but I'm sure that Carla and Sergio will speak about that.
Do you want me to read in Spanish?
Yes, please.
Ok, bueno, bienvenidos todos y simplemente presentar las presentaciones que vamos a tener más tarde. La de Carla Cadena Valdivia va a hablar sobre el efecto de la variabilidad climática en la salud e inmunidad del lobo marino de California. Y luego va a estar Iván Ramírez hablando de IGNIS, que es una aplicación para reporte ciudadano de incendios forestales. Y ahí ya después tendríamos una última presentación en inglés. So Victoria, if you want to present Selby's presentation.
Thank you very much. So yeah, and Zalby will talk a bit about automating some data scraping for rainfall data and telling us a bit why it's so important to actually have this rainfall data. So I'm not going to take any more of your time. We will swap then over to Nicholas that will start the first presentation for us. Thank you very much, Nick.
Thank you. I hope you can see and hear everything. Good afternoon. Well, it's afternoon here, but whatever it is, wherever you're tuning in from. My name is Nicholas Tukok, and this afternoon I'll be introducing you to the AutoESA Python library, which automates the exploratory spatial data analysis workflow, and it formed part of my honors research at the University of Pretoria here in South Africa. So to start off with, what exactly is exploratory spatial data analysis, or ESDA? So ESDA stems from ordinary exploratory data analysis, or EDA, which is a workflow or a set of functions that's carried out on what I would call ordinary data. So that's financial data or orders and stock data. And it makes use of functions such as histograms and box plots and scatter plots to gain a basic understanding of a data set before you choose what modeling techniques and you'll employ and how you'd further interpret the data set. So the addition of geometry or coordinates turns a data set into a spatial data set, and then we're concerned with ESDA, which is a similar process. So it will also have histograms and box plots and scatter plots and so on, but it will include additional functions such as the generation of choropleth maps and autocorrelation simulations. So what exactly is the problem that we're trying to solve here? So currently the ESDA workflow requires constant user input. So it requires someone to actually specify various parameters and exactly what functions they want to use to actually understand the data set that they're working with. It's quite a repetitive process. So it's the same tasks that are often done, but you'll have to repeat everything that you do for the next data set that you work with. And often it's kind of step for step. There's not much variation in the work that you do. So this can quickly become a time-consuming process, which then you're wasting your human resources within a company or wherever you may be working. The results generated in a manual ESDA workflow also are often generated individually, and these can be generated in a command terminal or a Python environment or something that can't easily be shared or saved and referred to later. So it's often difficult to pass that on to someone who might not be as technical as you. So what similar work has been done to automate the exploratory process? So there's a Python library called SweetFizz, which uses a single line of code to generate an HTML report, which we can see over here. So we have a little area for each variable with a whole bunch of metrics that describe its kind of shape and what you can further do with that, or you would rather interpret what you would do based on these statistics. And then there's a whole lot of graphs and various figures that will help you understand the data set. Pandas profiling is a similar library. It's pretty much exactly the same concept, just a different layout. So we can see on the side here, we've got a section for each variable with its associated statistics and some graphs. So let's have a look at the AutoESA library, which is my attempt to make something that automates this process. So it's based off of numerous dependencies. One of the major dependencies is the GeoPandas Python library, which is based off of the popular Pandas Python library. So it allows us to work with geodata frames, which incorporates a column for coordinates or geometries. And that allows us to import that data into PySol, which is a different Python library, and that helps us with various spatial metrics and such as autocorrelation measures, as well as things like defining your spatial weights matrix. So this is all then visualized in the other two dependencies, which are matplotlib and seaborn, which help us actually draw the plots and figures and choose applicable color schemes that will then be, that form part of the HTML report. So let's have a look at how one would use the ESDA library. So you would start off over here by importing GeoPandas, which is one of the dependencies. And we'll get to why you need to do that now. And then you'll import the AutoESA library. Unfortunately, it's not published yet, so this line 2 isn't possible, but hopefully by the end of this year it would be. So you'd start off with creating your geodata frame, which is why you had to import the GeoPandas library. So in this case, we are importing a shapefile, which is various wards in the city of Johannesburg, which is one of the major cities here in South Africa. So then using a small line or one line of code here, you'd then employ the AutoESA function, and that will generate a report that looks something like this. So it's an HTML report so that you can share it easily. We can see a quick plot of our study area here, which there's no reference data yet. So it will just actually help you understand the shape, not so much for orientation purposes. Then at the side here, we can see an overview of the data set. So what rows and columns have been included. So currently there's only support for numeric columns. So those are the ones that are included here. There's a descriptive statistics table. So that gives all your various measures for each of the variables, which in this case are the different population groups found in the city of Johannesburg and the various income levels, which was just used as an example for this demonstration. Then at the bottom here, we can see the sample rows. So a sample in this case is just the first and the last 5 rows of the data set that we used. Then along the top here, we've got the what I call the variable information pages. So we can look at the Black African population group within the city of Johannesburg. We can see a box plot of the values across the different wards, a histogram, your autocorrelation simulation with your reference distribution and your scatter plot, and then your LISA cluster map, which you can see is quite distinguished here due to South Africa's history. Then at the bottom here, we've got 4 different choropleth maps with different classification schemes, namely quantiles, equal intervals, natural breaks, and percentiles. And it always fascinates me how different these maps can look with the same data, but just with the different classification schemes that you can choose. So we've got a page like this for each of the variables, which is pretty much the same format, just with the different variable data. So I'm not going to focus too much on that. And then finally, we've got our correlation page. So on the left here, we have a correlation heat map, which is just the simple correlation statistic between each of the variables. And then sometimes that's not enough because just a value doesn't represent the relationship between those variables quite so nicely. So that's why I've included a matrix of scatter plots here just to uncover any hidden patterns. So just to remind you that that's all generated from this one line of code here. So if we have a look at our problem statement again, hopefully there's not constant user input now because the process is simplified. It's not a repetitive process anymore. It's just a single line of code. It's no longer time consuming. The results are generated not individually anymore. It's rather as a summarized report. And because it's in HTML format, it can be sent and emailed around, and most people with a decent web browser should be able to view it. It doesn't require setting up any fancy Python environments or R environments. So looking forward, what's in store for AutoESA? So at the moment, I'm continuing with it for my master's project. So there's a whole bunch of future developments that I hope to introduce to the public soon. And some of this is things like improved functionality. So currently there's only support for vector polygons. So there's a definite need for other data formats such as raster grids and vector lines and points. It can also be argued that it's necessary to include sort of an about page, which will in a sense be metadata. So it will include things like the default parameters, so what spatial weights, matrix, shape, and order you used, and things like the date the report was generated, which could influence your results. Then the one which I'm most excited about is the generation of a QGIS plugin, which introduces a graphical component, so people who aren't familiar with code can easily generate these reports through the comfort of kind of pointing and clicking in the QGIS interface. And then finally, it's only obvious to test the scalability and performance because of the 21st century and the need for most things to process the large amounts of data that we generate on a daily basis. So that's just a quick overview of what I've been working on and what I plan to do in the future. Very happy to introduce it to everyone, and I welcome any questions. Thank you.
Thank you very much, Nick. Do we have any questions? You're welcome to just speak. Mohammed?
Hello. Hello, Nick. I have a question.
Hi, go for it.
Hello. You have done a great work here. Thank you for sharing with us.
Thank you.
Okay. Does the input data should be in shapefile format, or we can use a geodatabase or KML, other formats?
So at the moment, the library as it is only works with GeoPanda's geodata frame format. And what you can do is there's a whole bunch of different formats that you can use to import data into a geodata frame, be it a shapefile or any other format that GeoPandas would support. So that's kind of out of the scope for this project. but as long as GeoPandas supports it, AutoESDA should support it too.
Thank you. Great job. Great work. Thank you.
There's a question in the chat from Cameron for you. So it's just about, does it need to be clean before you read it in? Can you just plug and play? Yeah,
So
are you ready?
I haven't really experimented much with that, but at the moment what it does is it identifies the numeric columns, numeric being how it's defined in Python. So I'm not too sure whether, I think numeric is integer and decimal. So then provided that each of the rows are in the same format, it shouldn't be an issue.
Nick, I have a question for you. First of all, congratulations for your work. I saw that you generated a lot of information. And my question refers to how do you feel using open source geographic information technologies, and what will be the advantages against using private owned technologies?
That's an interesting question. So I'm all for open source at this stage. So most of the dependencies are open source. So it kind of adds challenges if you then want to turn something like this into proprietary. One of the benefits of open source is that there's a supportive community. So the hope is that once I've finished my studies and it's out there for people to use, it's not me that has to maintain it for the rest of my life. It's something that I'm happy to play a role in, but actually it's a grouping of people that can keep it going and adding more functions and fixing any bugs that come to life.
Okay, thank you.
Thanks.
Any other questions? Okay, if there's nothing else, then thank you very much, Nick, for your great presentation.
Thanks.
Okay.
Thank you.
Next up is Mohammed. So he is calling in from Egypt, and he's also just started with his master's. So we're looking forward to hearing more about your work. Thank you.
Thank you. Thank you for this opportunity. Sorry. Thank you. Hello, everyone. My name is Mohammed Shimrouk, and I am from Egypt. My project is web-based GIS application for public services in Kenya City. I worked with geodatabases using PostgreSQL and PostGIS to build a geodatabase for the web system for public services. And in the back end, I use Python programming language and the Django framework, in addition to Leaflet. For the front end part, I used Leaflet, Bootstrap, Flat Icon, HTML, CSS, JavaScript, in addition to Heroku and GitHub for web hosting. This is my WebGIS structure for database and backend, front end. And here is a sample code for my model and admin page. Moving directly to the web system. Here we have a system titled the Kenya City Smart System for Public Services. And this is the home page. The web consists of 3 main pages. The first is the home page, and second, the Kenya Services map. And we have 4 categories for public services. Each one has its own map. and the admin page to control the system. We have here 4 map categories: educational services and health services, in addition to religious services and post office fire station. And we have here an interactive chart that shows the coverage of services in the city. For example, we have the high schools with 80% covered and 20% uncovered areas in the city. And here is the supervisor, Prof. Muhammad Aziz, and Prof. Ibrahim Dessouki, Dr. Hamdan, and me. For the resources and stacks, Python, Django, PostGIS, and PostgreSQL. For IDE, I used PyCharm, in addition to Leaflet, Bootstrap, Flat Icon. Moving directly to the web system, is a map for the schools, educational services. We have here the legend, map legend shows the data, kindergarten, primary school, and preparatory school, high school. Each one has its own symbol. Symbols derived from flat icon. We have the map switching panels. We have three base maps. First is OpenStreetMap and a satellite-based map, and dark base map from CartoDB. We have an enhanced search, but unfortunately it's in Arabic. We can search here for school and moves directly to school. We have here the locate to locate the user location on the map and shows the accuracy of the location. Toolbar to zoom in and zoom out through the map, which is being active for web and inactive for mobile users. Moving to the health map, health services. We have here icons, the pop-up functions for each service, and for the religious services. Once we click on the location icon, we can see the name of each feature, of each map feature. And the last one is the post office and fire station. We have here the post office, the name in Arabic, and the postal code, and the name in English. Moving to the admin page, Kena Smart Map admin. Once we log in, we have the authority to change or add users. The user's permission part we can here give a user permission to add or delete any data within any layer. Here, for example, we have user permission for ambulance, can add or change or delete. Once we assign a rule for a user, he can't do anything except this rule. Moving to the map layers, system map layers, Kena Service Administration. Here we can control each layer of the geodatabase layers using the Geos and GDAL libraries. We can go to the fire station here. You can see the descriptive data and the locational data. For example, we can try and add fire station. Let's type the name in Arabic. And in English, we can name it fire station. Here is the descriptive data. And for the location data, we can add the location. Yes, we're gonna switch the base map to satellite base map and choose the location of the fire station. I guess it's here. Once we click save, the fire station, named fire station and Matafi in Arabic, appeared in the management system here. Once we refresh the web map, here our fire station added. If we want to delete it, just select and delete. Appears a message to make sure that we are sure to delete it. Yes. Once we refresh the map, it disappeared from the map. And many other features to control the geodatabase. We can control it from QGIS just by add the geodatabase and control the whole system from QGIS. Thank you. That's it. Any questions?
Victoria?
Thank you, Mohammed. Yes, can you tell us maybe if this is being used by people at the moment, or are you planning on getting users still in the future, or was it just a proof of concept?
Yeah, it's not used by people, but the governorate here asked to get the application, and we have signed an agreement by the university and the governorate to have the rights to use it. And soon it will be live on the website of the governorate.
Okay, that's cool. Yeah, to have people that will use it daily. Yeah.
Yeah.
Any other questions? I see there's one in the chat from Nick for you. He's asking about how you decided about the priorities of the requirements. What was like things that you had to include and what was nice to have?
Yeah, I see. Thank you, Nick. I have defined some requirements. The minimum requirements for the WebGIS to work is to locate the user and give it the information he needed. But in the future release, we have some enhancements. I hope you can join me if you. The project source code is available on GitHub. If you can search for it.
Okay, cool. Okay. It's nice that it's online available.
Yeah, it's online available.
The
whole project source code here.
Okay. Any other questions?
I have one for Mohammed. Congratulations. Also very good job you done. I was also going to ask about if this was only an exercise, but you had already answered that. My question refers to if it was difficult to for you to find information, because I see here a lot of information, and it's amazing that you could get all that information. I guess it was not difficult for you to find it, or was it?
Thank you. Yeah, it's been difficult process to have this information since all the process, the information like this isn't available online, or at least part of it is available, but not all information. So I have to do a lot of paperwork to get this from the governorate and have it online. But I used the open source data like OpenStreetMap to have and help me and to enhance my locational data, and I review it and enhance it using the OpenStreetMap and satellite data to enhance the locational data. As for the descriptive data displayed in the pop-ups, it's hard to find, and no one gives you the required information. So it's minimum.
Well, that makes your work bigger. But if you have the data arrangement for future with the government, I think that you can make check-ins about that information, and you can enrich them.
Yeah, I hope so. I hope this is what's going to happen soon. Thank you.
Thanks to you.
Thank you.
Any other questions for Mohammed? Okay, I don't see anything. So thank you very much, Mohammed. It was very nice to hear about your work.
Thank you, Professor Victory. Thank you.
Okay, so next we have the wheat and maize Sentinel project by Atikul. Please fix my pronunciation with your name. But thank you very much for joining us. We're looking forward to hear about your work.
Okay, I think I'm audible right now.
Yes.
Yeah. So hello everyone. Good afternoon. My name is Atikul Haq. I'm from Bangladesh, and I'm doing my master's in geoinformation science and earth observation at University of Twente, Netherlands. And the topic of my thesis is variability of wheat and maize phenology from Sentinel-1 and 2 data, a case study in Brandenburg, Germany. So I'm still in the initial phase of my thesis, and yeah, this is more into remote sensing side of work, unlike the first two. So yeah, let's start. So let's start with what is phenology, and So crop phenology is the seasonal growth stages of crops, for example, sowing, emergence, flowering, ripening, etc. And why it is important. It has many agronomic applications, for instance, monitoring the growth stages of crops, timely irrigation, yield estimation, pest infestation, to name just a few. And so what is the research problem? The research problem is the previous studies that considered crop-specific phenology, they either took small area or limited number of fields in a larger area. And my current research will tackle this gap to take all the fields in the Brandenburg state of Germany and the latest 6 years of data. So as I mentioned, the study area is in Brandenburg state of Germany, where agriculture is the dominant land use, approximately 40% or 45% of it. And from the digital elevation model, we can see that elevation is more or less flat. And it has an extensive network of field phenology data, which will be used to calibrate and validate our model. So these phenophases, which are coming from the in situ phenology data, these are provided in DWD, which is abbreviated as Deutscher Wetterdienst, which is a German acronym, and BBCH scale, which is more used globally. So as my title suggests, I'm studying the two crops, winter wheat and maize, because these two are most important cereal crops in Germany. And as the right graph suggests, that the grown crops in Brandenburg are mostly maize and winter wheat. Yeah, and on the left side, we can see the distribution of these crops in a municipal boundary. Okay, so I'm dealing with 3 objectives here. Right now, I'm done with the first one, and I'm looking into 2 and 3. So the first one deals with the temporal profile from Sentinel-1 backscatter, which is VV/VH, and also the cross ratio VH by VV, and from Sentinel-2 EVI, enhanced vegetation index. And so I'll see from the temporal profile how they're corresponding with the field phenology data. That's my first objective. And the second objective is to calculate the phenometrics, which is remote sensing based phenology from those field. And I will calibrate this phenometrics using the field phenology data. And the final one, I'll validate those phenometrics, and also I'll try to see if there is any variability among the fields and among the years. and how can this variability be explained with the gridded weather data. So these are the data sets that I'm going to use, or I'm using right now. All are open source. Sentinel-1 and 2 are coming from European Space Agency. They are in quite good temporal resolution, which makes it really great for studying phenology. I'm using this from Google Earth Engine, which is also a free platform, a remote sensing platform to use. And the in situ phenology data is coming from German weather station. And the gridded weather data is also coming from the same source. And Germany has this field type data, which is coming from this source, and it's reported by the farmers. So it's also open, freely available in their website. So the first step is to pre-process the data, which is already done. A 10-meter internal buffer for the field type map, which is to ensure that there is no surrounding effects on the surrounding effects like any trees or surrounding fields into our analysis. And bigger fields are taken into consideration so that we have a minimum number of pixels in each field. And Sentinel-1, which is in the sigma naught right now in the Google Earth Engine, will be converted to gamma naught, which is more preferred in the radar community because it's radiometric terrain flattening. Radiometric terrain flattening is taken into consideration. And as we know, Sentinel-2 is an optical data set which is prone to cloud, snow, and cloud shadow. So these will be screened using a sophisticated model in Google Earth Engine. So the first objective was to explore the temporal profiles as so. I'm using the LOES or double logistic model to smoothen the time series so that we have some generalization about the time series, as well as to reduce the impacts of various outliers of the data. And upper envelope function is to avoid the biasness towards the lower values, and also to see the correspondence with the field phenophases. For instance, we can see that from April, it shows that the growing season starts from April, and then the harvest is around this corner. And from this, we can see that it has good correspondence with the field data. So shooting is around when it starts to peak. I mean, before starting to peak, years emerges around that corner. So yeah, we can see that it has a good correspondence with the field data so far. So the next objective is to retrieve the phenometrics from those temporal profile, which is still to be done because I'm still in the beginning phase of my study. So to retrieve the phenometrics, I'm proposing to use threshold or breakpoints, and multiple thresholds will be tested. For instance, for start of the season, 20% of total values for either EVI or cross ratio, 25%, and I'll see which one works best so that it has a better match with the field data. That's where the calibration part is coming, and which BVCH phenophases to link with my phenometrics based on those calibration. And from my in situ data, half of the data will be used to calibrate, and the other half will be retained for validation at the end. And finally, to link with the weather data, as we already know, in Europe in recent past, there have been some extreme weather condition. For instance, 2018, it was quite drier than the other years. So I'll try to see if this extreme weather condition has any effect on the phenology. And for that, a scatter plot will be generated between the two variables, phenometrics and also the weather. And through the results, a correlation between the two will be discussed, and also to see if there is any variability between the different places and also different years. So this is just some temporal profiles based on the 4 indices that I'm using. So this is for 2019. As we can see, a cross ratio VH by VV and also EVI from Sentinel-2 has really good correspondence with the field data. It clearly shows the signal of when the season is starting, when the season is ending. The VV and VH is a bit noisy, but yeah, when I calculate the phenometrics, maybe then I'll know if how it's behaving with the alongside the CR and also EVI. So yeah, that's it from my side so far, and yeah, thank you very much. Thank you, everyone.
Thank you very much. That's cool. It was a great presentation. Any questions from the audience?
I have a question.
Yeah.
Yeah.
Yes,
Hello.
Mohammed, go ahead.
Yeah, hello. Great work you have done here. But I have a question about the data. Do you use the data as it is from the satellite, or you have you do some enhancement like band ratio or other things?
Yeah, thank you. So for Sentinel-1, I'm converting the data into gamma naught, and from that I'm calculating the cross ratio and VV and VH. So there is not much of conversion for Sentinel-1. And for Sentinel-2, as I've mentioned here, I'm using the cloud snow and cloud shadow detection, and I'm deleting the values that have more cloud snow or cloud shadow, let's say, and I'm keeping the values that are up from the threshold that I'm setting up. So yeah.
Great, thank you.
Thank you.
There's questions in the chat from Cameron. He's asking about where did you get your data from? So I don't know if he maybe is referring to additional data apart from the Sentinel. And then regards with screening for clouds, how are you doing that?
Okay. So the Sentinel-1 and 2 data sets are coming from the European Space Agency. Those are already ingested in Google Earth Engine, as I've mentioned. And the in situ phenology data is coming from the German Weather Service. So they have this website. I think I can put down the link below. Just a moment. Yes. Yeah. So in this website, they have the phenology as well as the climate data set free to download for everybody. And yeah, what is the another question? Oh, so the next question was to regards with screening for cloud. So I'm following a literature for this. I forgot to mention it in the presentation. Maybe I can send it later. So they have already done this for Landsat 8, and some other people already incorporated in for Sentinel-2. So I'm just using his method to do the cloud screening and also snow screening. Yeah.
Atikul, congratulations for your work. My question refers to if you see if it's possible to apply this research in your country, in Bangladesh.
Yes, I actually have a plan of doing something in this part. So the only problem comes with the field type data. So in Bangladesh, we don't have a public data set for people to use where they have these field boundaries. That's the main issue of doing this kind of research in my country. But I think with some field works and as well as talking with the farmers, we can delineate the field type maps in GIS by digitizing or some other models maybe. So when we have this data, obviously this work is reproducible in my country. Yeah, because all other sources are open. So.
Okay, but wheat and maize are crops that you find in your country?
Not so much, but wheat is one of the major crop, I would say.
Okay, thank you.
Yeah, thank you so much.
Yeah. Any other questions? Okay, I don't see anything. So thank you very much, Atikul. I appreciate the presentation. It was great. I just want to check, is Patrick here for the last presentation of the session? I don't see his name. I just want to ask. Okay, it doesn't seem like Patrick is here. So we'll just take a short break, 5 minutes. You can get your coffee or whatever beverage, and we'll be back in a couple of minutes for the next session. Thank you very much.
Hola a los que siguen ahora. Bueno, nos tomamos 5 minutos para preparar la siguiente presentación, que ahora ya van a ser las presentaciones en español. ¿Tá? Bueno, gracias.
I see we have a couple of new people joining. Welcome. I'm just putting up the schedule briefly so you can see. We will have at least one Spanish presentation now and then followed by an English presentation again. We're just waiting to confirm the second presenter. Thank you. We will start probably in a minute or so again. Okay, we will start the next session now. So I'm handing over to Sergio. Thank you.
Okay, thank you everyone that is joining in these sessions. Now I'm going to switch to Spanish to present the next presentation. Bueno, vamos a presentar ahora la presentación, valga la redundancia, de Carla Cadena. Ella nos va a estar hablando del efecto de la variabilidad de temperatura en una fauna particular de los lobos marinos de California. Y ella es de una universidad de México, así que le doy la palabra para que presente.
Gracias. ¿Me escuchan bien? Bueno, Sergio,
Sí,
Víctor.
perfecto, sí, te escuchamos
Okay.
bien.
Bueno, mi nombre es Carla Cadena Valdivia. Yo estoy estudiando la maestría en Ciencias Biológicas en la Universidad Autónoma de Querétaro y el título de mi trabajo o de mi presentación es Efecto de la variabilidad climática en la salud e inmunidad del lobo marino de California. Y bueno, como una introducción pequeña a lo que dice en mi título, variabilidad climática, me refiero específicamente a los cambios que existen en mi zona de estudio, en la temperatura superficial del mar. Específicamente en mi trabajo, yo trabajo, valga la redundancia, con anomalías en la temperatura superficial del mar, que se refiere a cuánto se desvía o cuántos grados centígrados se desvía la temperatura del promedio que generalmente se espera. Y bueno, o sea, en el mundo hay temperaturas diferentes a lo largo de todos los océanos, y es una interacción que se da normalmente entre la atmósfera y el océano, y también se presentan como diferentes ciclos que son normales, ¿no? O sea, por ejemplo, hay fases que pueden ser calientes o fases muy frías y son normales, ¿no? Están dentro de lo normal. Sin embargo, se sabe que en los últimos años, debido al aumento de los gases de efecto invernadero, pues ha habido como ciclos muchísimo más calientes y que además son más frecuentes, más prolongados y cada vez menos pronosticables. Entonces, estos ciclos ya muy calientes o muy fríos se ha visto que tienen un efecto en los animales. Por ejemplo, pongo esta imagen de un lobo marino que se está muriendo de hambre literalmente. También se han encontrado animales más grandes como ballenas y pues también se tiene un efecto negativo en los humanos, ¿no? Por ejemplo, en la disminución en la pesca, en la cantidad de alimento disponible. Y bueno, como yo les comenté, yo trabajo con una especie que es Alophus californianus, que es el lobo marino de California, y específicamente yo trabajo con crías, que bueno, las crías son desde que nacen hasta aproximadamente 2 años. Sin embargo, yo trabajo únicamente con las que, bueno, con las crías desde que nacen hasta que cumplen aproximadamente unos 2 o 3 meses. Y bueno, es un mamífero carnívoro que se alimenta de peces y calamares principalmente. Y algo que es muy importante es que las crías son totalmente dependientes de la leche materna durante los primeros meses de vida, o sea, durante el periodo con el que yo trabajo de las crías, pues, de edad. Entonces, como son tan dependientes de las madres, pues las madres, que pues obviamente son hembras, se alimentan en la costa para estar muy cerca de las crías en todo momento y que no les falte alimento. Pero algo que se ha observado es que cuando hay aumentos en la temperatura del mar, las hembras comienzan a buscar alimento diferente y también tienen que desplazarse mayores distancias para encontrar alimento. Y bueno, hay 3 efectos principales que se dan por este aumento en las temperaturas del mar. Las hembras deciden pues desplazarse mayor distancia para buscar alimento, entonces las crías tienen que pasar mayor tiempo esperando para ser alimentadas. También, si las hembras no se van tan lejos, entonces deciden alimentarse de otros animales o peces que antes no elegían, por lo que la leche tiende a ser de menor calidad y también esto tiene un efecto en la salud de las crías. Y bueno, algo también que es muy importante es que obviamente toda la alimentación y todo lo que coman las hembras durante el embarazo, pues le va a afectar también a la cría cuando ya nazca. Y bueno, lo que hacemos en mi grupo de investigación aquí en Querétaro es ir a esta zona que es el Golfo de California en México. Comprende todas estas regiones. La que se ve en azul es el norte, la que se ve en verde es Ángel de la Guarda, en amarillo es el centro y en rojo es el sur. Y bueno, se colectan muestras en todos esos puntos negros del 1 hasta el 13. Y bueno, estas son las colonias reproductivas, es decir, donde se reproducen los lobos marinos y se colectan las muestras de las crías. Y bueno, estas regiones de diferentes colores sí tienen diferencias entre ellas, principalmente, no sé, en características oceánicas. Por ejemplo, la temperatura superficial del mar, la clorofila. Bueno, eso tiene un efecto también en la cantidad disponible de alimento para las hembras y, o sea, eso pues tiene un efecto en la salud de las crías también. Y bueno, ya en el laboratorio lo que yo he estado haciendo es trabajar principalmente con la sangre de los lobos marinos. Y bueno, ahí estudio cosas utilizando el microscopio y he visto algunas características de los eritrocitos, que son las células rojas que llevan el oxígeno a la sangre. Lo que principalmente hago es ver que la morfología sea normal. Aquí en el centro de la pantalla pongo unas imágenes. Esas son morfologías que se presentan en las células cuando hay carencia de vitaminas, cuando puede haber, no sé, pues anemia en las crías. Entonces, eso es lo que yo estudio y también veo si los valores son normales o son muy altos. Algo que también estoy estudiando en el laboratorio, bueno, son la cantidad de leucocitos, si hay conteos muy altos o muy bajos. pues como sabemos, estas células nos ayudan a defendernos de infecciones, de inflamaciones y de alergias. Y por ejemplo, si los números son muy altos, esto puede indicarnos que las crías están pasando por un proceso infeccioso o por un proceso de estrés, lo cual puede estar muy relacionado también con la alimentación y en el aumento en la temperatura. También algo que hacemos en los viajes a campo es medir a las crías y pesarlas, y a partir de eso se calcula la condición corporal, que es un predictor de cuántas reservas energéticas tienen las crías, es decir, de qué tan bien se están alimentando. Y bueno, también mido la glucosa en la sangre, que también es como un indicador de qué también se están alimentando las crías. En el caso de cómo yo vi la variabilidad climática o cómo estoy pues obteniendo los datos de temperatura en esta región, bueno, yo acudí a las bases de datos de la NOAA, la AirDAP, y bueno, es una base de datos que está abierta a todo el público y tiene muchísimos satélites para datos de todo tipo. Y bueno, lo que yo hice fue elegir un satélite que me diera información de toda la región de mi estudio y que además tuviera los datos desde que, bueno, de todos los años con los que yo estoy trabajando, que es desde 2012 hasta 2020. Y bueno, elegí un radiómetro de alta frecuencia, que es, o sea, es un instrumento que está a bordo del satélite, y bueno, está tomando imágenes recurrentemente alrededor del planeta y eso lo pasa a datos, ¿no? Y bueno, esos datos no solamente son oceanográficos, también son hidrológicos y meteorológicos. Y bueno, lo que yo he obtenido a partir de esos datos, pues es muchísima información. Entonces, pues yo la he analizado por medio de QGIS para también observar más o menos cómo se comporta la temperatura a lo largo de las regiones en el Golfo de California, y también he obtenido promedios. Algo también muy importante que obtuve a partir de estos datos es cómo es la temperatura tanto durante el embarazo de la hembra como cuando ya nacen las crías. Y en esta gráfica presento un resumen de los datos que he obtenido por región y a través de todos los años. Y si se dan cuenta, bueno, las barras rojas representan anomalías positivas, es decir, cuántos grados centígrados se desvía de lo normal. Y la verdad es que casi en todos los años y en todas las regiones me han salido muchísimas anomalías positivas de temperatura, lo que indica que realmente sí está aumentando la temperatura superficial del mar en esta zona. Y bueno, después mi trabajo ha consistido principalmente en analizar estos datos estadísticamente para ver cuál es el efecto que tienen en las cosas que yo estoy haciendo en el laboratorio. Y lo que he obtenido hasta el momento, todavía no acabo mi tesis, de hecho me faltan muchas cosas, pero lo que he obtenido hasta el momento es que cuando hay aumento en la temperatura superficial del mar, esto tiene un efecto en las células, tanto rojas como blancas, en los lobos marinos. He encontrado morfologías muy raras, valores muy altos de las células, cosas que generalmente no son normales en organismos que están sanos. También otra cosa que he visto es que cuando aumenta la temperatura también hay una disminución en la condición corporal, es decir, qué tan gorditas están las crías, y también hay una disminución en la cantidad de glucosa que tienen en la sangre. Y bueno, esto es muy importante puesto que en 2020 mi asesora de tesis y colaboradores hicieron un estudio en el que se dieron cuenta que en el Golfo de California ha aumentado muchísimo la temperatura superficial del mar sobre lo normal, y esto está estrechamente relacionada con el declive de la población. Para 1991 había 44,000 individuos del lobo marino de California en esa región, y para 2019 se calcula que ha habido un decremento del 65.2%, es muchísimo. Entonces, pues mi trabajo es muy importante para conocer los mecanismos por los cuales está disminuyendo la población en el Golfo de California. Y bueno, eso es todo. Muchas gracias.
Muchas gracias, Carla. Bueno, muy interesante tu trabajo. Supongo que voy a ser el único que va a hacer preguntas. pero voy a ver si alguien más quiere hacer preguntas y vamos a tratar de traducirla. If anyone wants to make a question, I will try to translate it to Carla. I hope you at least understood some of her presentation. But I will start with a question. Lo que yo quería preguntarte, Carla, bueno, muy bueno tu trabajo, te felicito. Y lo que primero me llamó la atención de que tú hayas elegido un tema de estudio tan lejano a donde estás tú, ¿no? Porque son unos cuantos kilómetros. Y si esa elección de la variable, que es la temperatura superficial del mar, fue por algún motivo especial, porque supongo que podría haber otras causas que influyeran en esa caída de la población de los lobos marinos. ¿Es que ya había algún indicio de que ese era la variabilidad a estudiar? ¿O crees que pueden haber otras variables que puedan afectar en ese decaimiento de la cantidad de lobos marinos que se está constatando?
Bueno, sí hay muchos antecedentes, solo que pues era muy corto el tiempo para ponerlo, pero sí se ha visto que en años, por ejemplo, cuando sucede el niño, el fenómeno del niño, que hay un calentamiento extremo, por ejemplo, sí disminuye la cantidad de crías que nacen. O sea, las hembras de lobo marino deciden no tener crías porque están viendo ellas que no hay alimento. Entonces, sí es como muy complicado, ¿no? Decir que solamente es ese fenómeno el que está afectando. También hay muchos otros, por ejemplo, muchas veces las hembras y bueno, en general los lobos caen en redes de pesca, y bueno, también la contaminación y enfermedades. Sin embargo, no se ha visto que pues esas razones tengan un efecto, por ejemplo, en la disminución de la cantidad de crías, de nacimientos. Y bueno, lo que pasa también en el aumento de la temperatura es que disminuye la cantidad de alimento disponible. Y eso sí se sabe, pues está en la literatura, ¿no? En todos lados. Entonces, pues sí, lo que estoy haciendo es pues ver si puede ser por eso, y también me falta meter muchos datos como clorofila, etcétera, que también los voy a obtener de la NOAA, pero hasta ahora es lo que he hecho.
Muy bien, bueno, muchas gracias.
De nada.
Esperemos que después en la grabación se pueda hacer una traducción de lo que están, porque es muy interesante y yo creo que ha despertado el interés solamente por las imágenes. Así que ahora, bueno, continuaríamos con la siguiente presentación. I will switch to Victoria to present the next work that is from Sylvie, I think.
Yes. Thank you, Sergio. And thank you, Carla. We were trying to Google Translate in between, so what we got was very interesting. So thank you for that.
Thank you, Victoria.
Okay, so I think this is the last presenter, unless Ivan or Patrick is here. You can just let me know in the chat. So last up is Zalbi. So Zalbi is going to talk to us a little bit about how he used different data sources to create a daily rainfall map and why that is important. Thanks, Zalbi.
Hi, I'm just setting up my screen. Can everyone see it?
Yes.
Yes.
Okay, cool. Hi, so I'm Zalbi, and my project that I will be presenting is an automated workflow for collecting and visualizing daily rainfall in South Africa. So this was my honors project for 2021 at the University of Pretoria in South Africa. So go. So rainfall is an important factor for short-term decision-making, particularly in the agricultural and tourism industries, which form very important industries within the South African economy. Currently, the South African Weather Service is the primary data source for the rainfall readings in South Africa. They obtain their data from 253 automatic rainfall stations that are spread throughout the country. However, as you can see in this map, between the rainfall stations, there are very large gaps, which leads to many locations rainfall data going undetected. Web scraping is a technique that will allow us to collect the rainfall data from various online sources to try and fill in these gaps in between the stations. APIs are a web scraping technique that will make it easy to perform the web scraping of the rainfall data. So therefore, through the use of an API, an automated workflow can be developed to scrape rainfall data from different online sources in order to create a comprehensive data set of rainfall readings that can be further visualized on a web map. So the question is, what is the problem that this automated workflow plans to solve? As previously stated, several locations rainfall readings go undetected in South Africa due to our weather service's uneven distribution of the rainfall stations. There are other online resources where one can view the rainfall data, but because of all these different resources, it's difficult to view this data all in one place. So currently there was no automated workflow that scraped the data from the South African Weather Service and other data sources and to combine this into a complete and comprehensive data set and then to visualize it on a web map. So this is what this automated workflow plans to solve. The workflow was developed using various Python libraries as well as other open source tools. So the two data sources for the project for the workflow is the South African Weather Service text file that they upload every morning on their website at 8 a.m. The other data source was Open Weather Map Developers API, which has an accumulated precipitation parameter. This parameter provides the rainfall readings for a given location for the previous 24 hours. Other sources were also looked at, but they were not, we weren't able to use them for this project due to various reasons. In order to perform the web scraping, Request, which is a Python library, was used. It's a simple HTTP library used for HTTP requests. When the data came in from the different sources, it wasn't in a format we could use or combined together. So this required data cleaning. So we use NumPys, Pandas, and Re. Both Pandas and NumPy are high-performing libraries, allowing for easy-to-use data structures. However, Re is a regular expression library and was used to extract the station names and their corresponding rainfall readings from the South African Weather Service's text file. Once the data is scraped and cleaned, it needed to be stored. The rainfall data for the workflow is currently stored in Google Firebase's real-time database. This is a cloud-based, NoSQL database that stores data in a JSON format. It is used in the workflow due to its reliability and scalability characteristics. This tool is very easy to use and was great. It was great to integrate this into the workflow. Like I said, it would be great to visualize the data on an interactive web map. And to do that, I used Plotly. Plotly is an open source Python library and is used for designing and sharing interactive visualizations. It is well known for its ability to create quick and easy figures. I'll show you the web map in a moment, but it's a combination. The Plotly allowed me to combine two types of maps, so a heat map and a scatter map, all in one place. A requirement for the workflow was that it needed to run automatically. So this was done every morning and it needs to show the rainfall for the previous 24 hours. In order to run the workflow automatically, we use DeepNote, which is a notebook that runs in the browser and allows for easy collaboration. DeepNote makes use of virtual machines in the cloud and reduces machine setup time. For the project, we just used the starter plan. This allowed us for 50 hours free use per month, which was more than enough for what we need. So once the workflow has successfully run, it also sends an email out to inform us that it has run successfully. The reason why DeepNote was selected over other tools was because it didn't require any major changes to the script that had been developed up until this point. So now on to the results. Okay, so this is the interactive web map that is produced every day once the workflow has successfully run. The workflow starts running every morning at 10 o'clock and takes about 15 minutes to run successfully after it's scraped from the different sources, cleaned, and stored the data. The map consists of a heading that you can see at the top here that provides the units as well as the data. As you can see, today is the 23rd of February, so this was for the previous 24 hours. On the side here is a range or a scale to show us visually what the colors mean. So the darker the color, the more rainfall occurred at that location. If you click on the map, you can get the longitude and latitude along with the rainfall readings in millimeters. Okay. As I stated previously, it consists of both a scatter map and a heat map. The reason why I decided to combine both was, so I'm going to click off the scatter map now. The heat map is fine when you want to view the rainfall for the whole of South Africa, but the moment you zoom in, it gets rather patchy. So I decided to include the scatter map, which, as you can see, I clicked off the heat map, which is better to view when you want to zoom in onto a particular location. It uses bubbles, and the size of the bubbles also represent the amount of rainfall that occurred at that location. If you would like to download or view the map at a later stage or anything like that, you can download the map by clicking this button, and it downloads it to your local device so that you can go back and look at it later on. So I can show you. So it downloads the map for the area that you zoomed into, and it has all the other features on it as well. The map is currently hosted using Git pages. If you would like to view the map, interact with the map, you can just scan this QR code on the right-hand side. All documentation and anything related to the project is stored on my Git repo, which you can find on the left-hand side here, the QR code. Okay, so recommendations for future work. So like I said, this is currently only using locations within South Africa. So it would be great to maybe to include locations outside of Africa and create like a workflow that uses locations from all around the world, or maybe Africa at first and then go larger. I would like to include more data sources because the more data sources we have, the more comprehensive the data set will be, and the less gaps and more accurate our data will be. And then finally, the workflow could include other natures of data or be used with other natures of data, such as COVID or anything else that you feel like you can scrape off of the internet and have a location attached to it and represent on a map. So yes, any questions? Oh, thanks for putting the link in the chat, Victoria.
Thanks, Zelby. Any questions for Zelby? Do you have something, Sergio?
Well, I'll try to. I find it very interesting, this presentation and all the work you've done. Congratulations for that. I would like to ask you if had you shown this to the authorities in the weather service yet, or are you planning to show to them this work that you are doing?
No, not yet. So I'm working, well, the project was done within our geography department at the University of Victoria, and I was working with the one of the meteorologists there, and from what I know, we haven't shared it yet with any of the authorities for them to look at or anything like that, but it is, yeah, you can access it through the website on the department's website, yeah, but it hasn't been shared, no.
I think you should.
Maybe.
Just to correct
Yeah.
Zalbi, I think Zalbi has left the university already, and the other supervisor is a meteorologist that works a lot with the weather service. So she's actually been sharing it with them to get feedback, and we have another student that will actually continue with this work now this year. So yeah. So a lot of things are happening with Zalbi being gone already, unfortunately.
Okay.
There's a question from Nicholas for you.
No, there isn't at the moment a cost related to hosting my web map.
Is there, do you think there will be any costs in the future?
It's not something I have looked at recently, like, yeah, there could be, I'm not too sure. But the hosting was done last minute, not last minute, but yeah, before the deadline, so it was a bit of a rush. I didn't really look into future costs.
Any other questions?
Hello, Prof. I have a question.
Yes, go ahead, Mohammed.
Yeah, I have a question here about the data. Is the data available online or data used in this project?
Yes, so the text file that we use from the South African Weather Service, you can find on their website. Do you mean the data once it's been cleaned, or prior to cleaning it and it going through the workflow?
No, my question is about the data. Is it available online so you can access it? If it's a web application, access the data from online resources.
So
it's update itself.
So the clean data you can't access you can't download it, but the sources that we use, you can download it or get it from the relevant websites of the original sources.
Yeah, so you need to have the data to process it. You can't access it through the web application or through the...
No, you can't access it through the web application, no.
Yeah, you have done a great job here, great work.
Thank you.
Thank you. Thank you.
Thanks. Any other questions? Okay, I don't see anything, so thank you, Zalbi.
Thank you. Bye.
Okay, let me just ask one last time if Ivan or Patrick is here.
I cannot see them.
Yes. Yeah, okay. It doesn't look that way. Okay, so I think that has brought us then to the end for today. Thank you very much for everyone that joined us today and all the students that participated in the competition as well as presented their work today. It was really nice to see all your work. Thank you to people that woke up at 6 o'clock in the morning to be here and things like that. We really do appreciate that. So yeah, thank you all.
Thank you, Prof. Victoria. Thank you, everyone. Thank you. I have one last question, please.
Yes.
It's about the Spanish presentations. Can we have in the future a brief in English?
Carla?
Yeah, actually, I will publish an article, but I don't have a date yet, so I will share with you when I have it.
I hope so. I'm waiting.
Yeah.
Thank you.
Cool.
Well, thank you all. It was a pleasure to join to this presentation and to be partnering with Victoria. And I hope it is not the last one. I think it's only the first one, and that we'll have more in the future.
Yes,
Thank
definitely.
you, everyone.
Okay.
Thank you.
Have a good day, all. Bye-bye.
Bye-bye. Thank you.